Hello everyone, today we are going to perform an experiment which is related to the comparison of the EMF of the two primary cell by using potentiometer. Now in this experiment we are using a device called potentiometer which consists of 5 to 6 wires, each wire of length 1 meter. Now the potentiometer works on the principle that the potential difference across the end of the wire is directly proportional to the length of the wire. That means if V is the potential difference across the end of the wire and the L is the small l is the length of that wire, in that case V is directly proportional to the L, small l. Now as per Ohm's law, the potential difference across the end of the wire is directly proportional to the current flowing through that wire. In that case V equals to IR, and the resistance of that wire is equal to the rho L upon A. In that case R equals to rho L upon A. If you put the value of R in the equation V equals to IR, we will get uh, V equals to I rho L upon A. Now V upon L is equals to I rho upon A, where I, rho and A are constants, so V upon L is also constant, and which is equals to the small k, which represent the potential gradient, and the unit of potential gradient is volt per meter. In that case we have V equals to k times of L. While performing this experiment, we required following apparatus: potentiometer, two-way key, jockey, a source of DC supply, Lagrange cell, Daniell cell, rheostat, and a galvanometer. Now we are going to discuss about the Daniell cell. We have the figure of this Daniell cell, and in this figure we see that it consists of a copper vessel containing a concentrated solution of copper sulfate. In copper sulfate solution, a porous pot is immersed which containing a dilute sulfuric acid. A zinc rod immersed in that porous pot serves as a negative electrode. The copper vessel itself serves as a positive electrode. Now the following reaction is going to be happen in Daniell cell. At the negative electrode, zinc react with sulfuric acid and form zinc sulfate hydrogen and generate two electrons. This hydrogen will react with the copper sulfate solution and form H2SO4 and a positive copper ions, which deposited on the vessel of the copper and gives positive charge on that vessel. Now we discuss about the Lagrange cell. The figure of that Lagrange cell shown here in the slide. It consists of a glass vessel containing a solution of ammonium chloride in which a zinc rod is immersed in that solution and serve as a negative electrode. A porous part is immersed in a glass vessel containing carbon rod and a mixture of manganese oxide and a powder of charcoal. The following reaction takes place at the electrode. The carbon rod acts as a positive electrode and zinc rod as a negative electrode. The ammonium chloride decomposes into ammonia and chlorine ion as now these chlorine ions will react with the zinc and form ZnCl2 and generate two electrons at negative electrode. These two electrons will react with ammonia at positive electrode and generate hydrogen, which further this hydrogen further will react with magnesium oxide and form Mn2O3 and water. Mn2O3 will react with the oxygen in atmosphere and form MnO2. Now we have a table here which consists of ammeter reading null point when E1 is in circuit and its the corresponding length L1, and null point E2 and its corresponding length L2, and we have to write these readings in this table, and we have to take the ratio of this L1 and L2, and through that we are going to find out the ratio of this A1 and A2 by putting the value of this L1 and L2. While performing this experiment, we must have to take some precaution here, like that all the connections should be neat, clean and tight. Do not keep the connection of the circuit for a long time. The positive terminal of the batteries E1 and E2 should be connected at point A. We have some sources of error arises during performing this experiment, like the screw on the instrument may be loose, the plug may not be properly inserted, and the wire may not have uniform thickness. Perform this experiment here. Now if you see this is a device which we call potentiometer. It consists of 4 wires, each one of length 1 meter or 100 centimeter, you can see. This one is the scale to measure the length of that wire. Now we have this rheostat which is used as a variable resistance. This is the battery here, which has positive and negative terminal. This is the Lagrange cell which we already discussed in the slide. This one is the positive electrode, and this zinc rod acts as a negative electrode. Now, this one is the two-way key, plug key. This is again a negative electrode, and this copper vessel acts as a positive electrode. Now, if you see this, the negative terminal of this battery is connected to the one of the terminal of the rheostat, and which further connected to this terminal B. Now, the positive terminal of this battery is connected to the terminal A, and all the positive terminals of the cells, primary cells, are connected with this terminal A. Now, the negative terminal of these cells are connected to this key, plug key. Now this galvanometer is connected through this key again. Now the another terminal of this galvanometer is connected to the jockey, which move on this wire. Now we are going to take the reading in this experiment. For that we remove a key from this plug key. In that case, this Lagrange cell is connected with this circuit. Now we are going to take the reading. Now if you see this, you are getting a null point, and now correspondingly we are going to measure the length of the wire here, which is around 203. The galvanometer shows null deflection here, and we are going to just measure the reading here, which comes about, if you see this, which comes about 200. So this is the null point, and we can measure the length of the wire. We can measure the length of the wire. That is 203 centimeters. Now we can put the reading in this table here. Now we are going to write down the reading here. That is 203 centimeter when this Lagrange cell is connected in the circuit. Now one important thing I am going to tell you here, the ammeter is not necessary to connect in this circuit, so we are not taking the reading of this ammeter, we are putting dash over here. It is not necessary to put ammeter in this connection here. Now again we are going to find out the balancing length for the Daniel cell. For that we are going to put key, plug key in this two-way key, and now this Daniel cell is connected in the circuit and we remove the another key. You see this? The only Daniel cell is connected in this circuit here. Now we are going to take the reading again. Which comes around, you see this, 143. You are going to write down the reading for the balancing length is 143 centimeter. Now we have these two values. The balancing length when Lagrange cell even in the circuit, that is 203 centimeter, and the balancing length when the Daniel cell in the circuit, in that case the length of the wire is 143 centimeter. We are going to take the ratio of these two and find out the ratio of this EMF of these two cells, that is 203 upon 143. The value of this comes out to be around 1 point. Around 1.41. That comes out to be 1.41. Now similarly we can find out the another reading when these cells are connected in the circuit. Thank you.